All right, welcome back, Hononegah Honors, Algebra 2. Section 6.2 is on the natural base e. Now, the history of mathematics is marked by the discovery of special numbers such as pi or I. Another special number is denoted by the letter e. This number is called natural based e. Um, just talking a little bit more about this. Remember pi when you guys were in geometry or maybe when you were in middle school, 3.14? Well, there's another one that is an e. So natural base e is an irrational number. Now, this is how they actually calculated natural base e. So 1 plus 1 over x raised to the x power as you get closer and closer to infinity approaches 2.71828, and again, it's an irrational number that would go on forever. So dot, dot, dot. So now, anytime we use E, we're going to use a calculator. And so there is an E button on your calculator. As those of you are pulling out a graphing calculator right now, we will find that E to the first power is 2.718, so on, so on. So again, we will use a calculator on this, and I'm going to go ahead and pull up my calculator just to show you where it's at. And so E is located on the left-hand side. You'll see the E raised to the x power. So in the blue. So looking at this particular question, I found E. It's right here. Whoops. So second ln is an E. And so if I wanted E, let's say to the first power, again, that is where we get that 2.718 number. So there's where the E is located. So as we do these problems, we'll find E. All right, well, E has the same properties as any other. If you have an E raised to the second times an E raised to the ninth would be an E raised to the 11th. So again, the rules of exponents still apply when you have the same base. This would be 5e to the first, and then we got 2 to the fifth, e to the negative 15x. Now, I wouldn't really like leaving that with a negative power. I would say that we should write that as a positive power, so putting e in the denominator because it's a negative power. But ultimately, rules of exponents still apply. Graphing now with e. So we are going to graph natural base exponential functions like y equals a, e raised to the rx. Now, if it's a positive x, okay, that will be exponential growth. So as long as the r value is positive, okay, then it's going to be growth. And if the r value is negative, so notice you have a negative in the exponent here, that would be exponential decay. So let's actually graph, and we're going to use a graphing calculator for this. 2.5 e to the x. So I'm going to go back to the graphing calculator, and I'm going to type in y equals 2.5 e raised to the x power. Let's graph. So notice exponential growth like we talked about before, and we're going to go ahead and hit second graph and get a table of values here. And so we're going to just graph a few of these points just to get an idea as to where you're talking about. So notice it's very close to the x-axis, and then that's the asymptote, and then it's going to go up from there. So 0, 2.5, 1, 6.7. So my XY chart, 0 was at 2.5, 1 was at 6.7. And then -1, and again, these kept getting closer and closer and closer and closer to the x-axis. And then at 0, it went to 2.5 and 6.7. So again, exponential growth. Now, it does ask if it's growth or decay, and this would then be growth because, again, you have a positive value of x. Next one, e to the negative 0.2x. So again, this would be decay. And let's go and pull our graphing calculator out so we can graph it. So it was e raised to the negative 0.2x. I believe that's what it was. Let me double check that. Yep. Graph. So notice this would be exponential decay, and it's much more slight. And so I'm going to graph a bunch of points here, so I'm going to have to write these down. So 0, 1, that's fine. And let's go a little further up. Let's go like -7 is a 4, 4.05. So negative 7 was 4.05. And again, I'm just trying to get more points here. 0 was at 1. And so it goes a much more gradual, and it will not cross the x-axis. So there you go. Next one. New formula now. Remember I told you we would give you formulas along the way. On section 6.1, we gave you exponential growth and exponential decay formula. This is anytime compounded continuously. P, just like previously, is the initial amount, like how much you're putting in. R is the rate, and T is the time. And now time in this particular formula is always in years, so you do have to be aware of that. So if they give something to you in months or they give something to you in something else, make sure that you talk about that one's in years. And then this is the ending amount, so how much you're going to end up with. So P is principal, R is rate, and it's always expressed as a decimal. All right, here we go. You and your friend each have accounts that earn the annual interest compounded continuously. The graph for the balance of your friend's account and the balance A of your account would be given by the formula. So there's a model. Which account has a greater principal? So again, looking at the initial amount, your friend started off with $4,000 and you started off with $3,900. So your friend had the higher principal. Now, who has the higher amount after 14 years? So at 14 years on the graph, it looks like your friend is a little over $9,000. Let's see how much you're going to have. So 3,900 e to the 0.05 rate times 14. So pull out a calculator. 3,900 times e raised to the point, was it 05 times 14? Let me double check that here before I hit enter. Yep. And so enter. So you got $7,853.63. So $3 and I don't remember what it was again. 64 cents rounding. So who's got more money? So your account has $7,853. It looks like your friend's account has about $9,000. So again, your friend made out with more money in the end there. Okay. Next one. Homework assignment then. Fairly quick lesson today. Please make sure you ask questions if you have any about E. Starting on the next lesson, things are really going to start picking up in this particular chapter. We really get off to a little bit of a slower start in chapter 6, but then we'll start really picking up in section 6.3. So if you have questions, talk to your teacher, and good luck.